Alright, let's look at the second example. This one's a bit involved. It might take just as long as the first example did. Given the polar curve, r equals 3 cosine 2 theta, for theta in the interval 0 to 2 pi, okay, so I can only have thetas there, determine which of the following lines are tangent to the curve at the pole. Tangent to the curve at the origin. So let's think about this real quick. If I have some kind of polar graph, I don't know what it looks like. Maybe it's like it's like a cardioid or something. Well, that wouldn't do, would it? Maybe it's like something like that. I don't know. The only way, my graph can go through the pole, the origin, is if r is 0. That means I have a 0 radius. That's not somewhere out there. So like the only way I can have a graph going through the pole is if r is 0. That's super important to understand. Hopefully you do understand that. Suppose I had the graph from the other time. R at this point is that distance. So that point is not at the pole. But r at that point, at the origin, well, that has to be 0. Otherwise, it would be either out here or out there if we're looking at pi over 2. So there you go. For us to have a tangent at the pole, it means r has to be 0. That's the first piece of information that we need. So when is r equal to 0? So I'll just take my equation and set it equal to 0. And I can divide off the 3. And now I just need to figure out where this is, what values of this makes cosine into 0. So like 2 theta has to equal something so that cosine is 0. Well, I'm going to do a variable change. I'm going to do a substitution. So really, I'm going to say when is cosine of alpha equal to 0. Now, I normally wouldn't do that. I would just say when does 2 theta make cosine 0. But I feel like that might confuse people. I don't know. Maybe this confuses you. I don't know. But now I can just think about regular cosine. When is cosine 0? Well, when alpha equals, I guess, cosine is 0 when alpha equals pi over 2 and 3 pi over 2. And I can't do anything more. Actually, yes, I can. Here's an interesting thing. We're looking at 2 theta, so stuff happens, but so I'm just going to keep going. So that's pi over 2, 3 pi over 2, 5 pi over 2, and I'll write a couple and keep going. You're thinking, wait a minute, this is past 2 pi. Yes, it is, but this is for alpha, and I'll show you. Hopefully it'll make sense later on. 5 pi over 2, 7 pi over 2. Let's do one more. If I need more after that, we'll see. 9 pi over 2. Okay, so alpha equals all those things. Even though theta was restricted between 0 and 2 pi, alpha is not. So let's go ahead and figure out what theta would be. So like here, if I divide it by 2 and divide by 2, that's the same thing as multiplying by 1/2. So really, to get theta, like theta, it'll be all of these multiplied by 1/2, because that's what I want. I want theta. So that's what I'm going to do. And there you have it. See, before, 5 pi over 2 was larger than 2 pi, but 5 pi over 4 is not. 8 pi over 4 is 2 pi. So as long as we're good there, then theta won't be going over. So this would be 7 pi over 4. And then, this one doesn't work. 8 pi over 4, that's 2 pi, so this is bigger than that. So that one doesn't work. So those are all the values that make r 0. Those are all the values between 0 and 2 pi. There we go. But it's not asking for what values make r 0. We just need that information. Now we need to figure out what the slope of this thing is at these theta values, because once we find the slope at those theta values, that'll tell us the slope of our polar curve. And then here, the slope is 1, so we can just compare it. Slope is 2, slope is -1, -2, and 0. So that's what we're going to do. Let's find the derivative of this and plug in these theta values to find out what the slope is at those points. Whoops. So, the derivative. You should try it on your own, but I need to write down my y, my x, and then take the derivative of those separately and then plug stuff in. So I'll write out the derivatives, the derivatives first. So I wrote out y and took the derivative. Maybe you should pause it and try that for x. I'm going to do that for x and dx d theta. So there we go. Now I can actually get dy dx. That's just dy d theta over dx d theta. So I'm going to do that. Actually, maybe you should try this, but I'm going to plug in things. I'll plug in these 4 theta values. It'll turn out that I actually didn't need those, but it'll be okay. Because remember, what I'm trying to do is first figure out where this goes through the origin. That's by setting r equal to 0. Then I'm figuring out the slope at those theta values. So figure out where r is 0. Okay, great, did that. Now I need to figure out the slope at these theta values and then compare it to these slopes. And I'm going to actually let you do that because I feel like it'd be better if you're doing that. You actually get a +1 for some of these slopes and a -1 for some of these slopes. So the ones that would work are the slopes with +1, that. So that one works, A, and a -1. So that slope. So those are the answers. You should verify dy dx. Hopefully you did that on your own. And then plug in these and see what you get. You should get +1 and -1. And that's all. Hopefully you're satisfied with the steps of that. I hope that makes sense.